A continuous random variable has an exponential distribution with its lambda equals 0.6. So the expected value, this is just from formula from our previous video, is 1 over 0.6. 1 over lambda, 1 over 0.6. 0.6 is also 3/5, so this is equal to 5/3 or 1.666. And our variance, our standard deviation, my apologies, of x is just equal to 1 over lambda as well. So good times. And so this is equal to 5 on 3 as well. So we've got our exponential probability density function values for expected value and standard deviation based on this particular case, based on our formulas. And then we have our probability as well. So C, our probability that x is greater than 3 will be equal to, I'm going to do it this way to avoid limiting functions, the integral between 1 minus the integral between 3 and 0 of 0.6 e to the negative 0.6 x dx. So instead of saying let's find what's above 3, I'm saying let's find what's below 3 and subtract it from 1 is another way you can do this question. And so that's 1 minus, I'll do this like it's tech free. So of course I get 0.6 e to the negative 0.6 x over negative 0.6, which always works out nicely. We get that lambda cancellation. 3 and 0, they cancel out. The negative carries, so I get 1 plus brackets e to the negative 0.6 times 3 minus e to the 0, and that will be equal to 1 plus e to the negative 1.8 minus 1, which just equals e to the negative 1.8. And I'm sure if you play around with that enough, you'll be able to find a generalization there as well, but for whatever that value is, e to the negative 1.8. And of course D is very similar, but this time we're looking at between 1, x and 2, and so we're trying to find the integral between 2 and 1 of 0.6 e to the negative 0.6 x dx. And if I slide along here now, I can do that calculation as well. It is 0.6 e to the negative 0.6 x over negative 0.6 between 2 and 1, and that will be equal to 0.6, well that cancels out actually, so negative e to the negative 1.2 minus negative e to the negative 0.6, which of course is equal to e to the 0.6 minus e to the 1.2, so e to the negative 0.6 minus e to the negative 1.2. And that will give you your area underneath. And again, if it was tech active, you could then calculate those. You should get answers that are between 0 and 1, and whatever you get for this value here should be a bit more than that value there, but maybe not the 1 minus, so maybe not above 3, but either way.